Identify the measurement described. So here we're looking for the measure of angle BAC. So we start at B, we head towards A, and then to C. So that's this angle here, which is 42.47 degrees. You have a couple of side lengths and another angle to identify. Using these line segments to form a quadrilateral. How do you think your quadrilateral compares to those made by the rest of your class? Do you think anyone else created the same quadrilateral? Well, mine was slightly slanted. I think that the others are probably going to create a square. I do not think my classmates made the same quadrilateral. On this slide, it should have all of the quadrilaterals that our classmates made, but again, because I'm doing it independently, it's just the one that I made. You would be able to see whether there were any that were the same or any that were different, and we could line up a point, a side, or we could flip the shape around to see if we can get it to match up. Try using these segments to form a triangle. How do you think your triangle compares to those made by the rest of the class? Do you think anyone else created the same triangle? Well, since they are all 5 units long, I created what's called an equilateral triangle. And I do think that my classmates will have the same triangle on theirs because I could only get it to line up in one spot. So again, all of the triangles would be here, and I would be able to line them up by rotating and matching the sides up together. Earlier, all the line segments were the same. Try using these different line segments to form a quadrilateral. Do you think anyone else created the same quadrilateral? I do not. I think there were multiple ways we could have lined up our segments. So here we would see our classmates and see if they were similar or if they were all different. Here are some more. Okay, so there's one way we could arrange them, but I could also have switched. Oh, there's another. And then there's another way that we could do it. So how are those lines? Here are those same line segments. Try to make a quadrilateral that is different from the one you just made. So you just saw that I was able to make a rectangle, a parallelogram, and then a different shape, a different quadrilateral. How do your quadrilaterals compare to each other? Well, they all have the same perimeter because all the side lengths all are the same. We can see that the angles inside of the quadrilateral change. Here I have an acute angle and an obtuse angle, but in the rectangle, all of the angles were 90 degrees. Then it says, how do you think your quadrilaterals compare to those made by the rest of the class? Do you think anyone else created the same quadrilaterals? I think there are many different ways we can arrange these side lengths, so I don't know that we'll have the exact same quadrilateral shared by a classmate. So here are a couple that I have made. The rectangle, I could see people having the same rectangle because there's only one rectangle that could be created with these four sides. But as for these shapes, this parallelogram can get slanted even further, and then these could be angled outwards more or more narrow. Now all the line segments have different lengths. Try using these lines to form a quadrilateral. There's one. How do you think your quadrilateral compares to those made by the rest of your class? Do you think anyone else created the same quadrilateral? Well, let's see if we can modify this to see if our classmates might have got a different quadrilateral. Ooh. So there's a really narrow quadrilateral. So since I was able to create two different quadrilaterals, I'm going to guess that my classmates did not create the same quadrilateral that I did. So there's the one I made second, and then you could also think about the one that I made earlier. When the side lengths are all equal, we all made the same equilateral triangle. Do you think we will be able to make different triangles when the side lengths are not equal? Explain. I think we will be able to make different triangles because there are different orders in which we can arrange them. So here it was 5, 5, 5. So it didn't matter where you put it, it was still going to go 5, 5, 5. But if they're different lengths, we might be able to create a different triangle by changing which one is placed where. So here I have a 3, a 5, and a 5. So I can make what's called an isosceles triangle. Let's see if I can arrange it any way else. I was able to create it in a rotated version, but it's still the same triangle. So how do you think your triangle compares to those made by the rest of your class? Do you think anyone else created the same triangle? I was only able to create one triangle from this, so I do think that my classmates made the same triangle. That word oriented is describing how it is positioned on my screen. So I had it where it was pointing up. Now it's pointing off to the side. I could have rotated it or flipped it over, but it still was the same triangle. So we would be able to match up the triangles from mine and my classmates by matching up a point or a side. Now all the segments are different. Try using these side lengths to form a triangle. I was able to create, it looks like a right triangle. Let's see if I can position it in a different way. It still looks like a right triangle, it just looks like a flipped over version. So how do you think your triangle compares to those made by the rest of your class? Again, I was only able to get one triangle out of these three sides, so I think that my classmates would create the same triangle. And then on this slide, we would be able to see that they all matched up. Let's see whether a different set of side lengths can finally make different triangles. Try using these line segments to form a triangle. Okay, so there's one that's an obtuse angle here. It still looks like the same triangle, but it's just rotated around or flipped over. The triangle I made was the same no matter how I tried to arrange it. So I think my classmates will create the same triangle. Now we have seen that the side lengths, when we're given 3 side lengths, it creates a unique triangle. It always makes the same triangle when we are given those 3 side lengths. But when we had the side lengths given in a quadrilateral situation, it did not guarantee that we would all get the same quadrilateral. So now that we've looked at some sides, let's look at some angles. It says try to construct a triangle with the given angle and sides. So I could place this here and this one here, and it would create a triangle. Do you think you could make a different triangle? Well, what if I placed this piece in a different location? Oh, there's a different one. So yes, I do think that I could create a different triangle. Try to construct a triangle with the given angle and sides. Okay, so there's already a side here. Let's place this side along this part of the angle and see if we can connect them. Well, that doesn't work here. I won't be able to connect it to this red dot. What if instead I started with this one along this angle and tried to connect them here? Well, that doesn't fit either. I won't ever be able to make those red dots touch. Oh wait, I see, this is not a side, that's just indicating where the angle should be. Okay, so line that up there on the angle. Oh. And I am able to create one. I have this thing frozen in there. There we go. And then let's see if I can rearrange it. It's just changing the position of that side. It's moving the triangle to a rotated version, but it still shows the same triangle. But if I put the 3 here and the 8 here, does that change the triangle? Because then I have the 8 in the middle and the 3 and the unknown side length here. So it does look like I get 2 different triangles. Try to construct a triangle with the given angles and side. So let's place this piece here and here. And then we're going to want to position this angle coming out of it to create a triangle. So there's one possible triangle. Let's see if instead we put the 7 in a different location. What if we place the 7 along this side? It does look like we're able to create different triangles. There's a large one and a small one. So you can see there's one of the versions. And then if we swap it out, it's going to pop up a different version. So we can flip through those different versions where we had the angle and only one side, the angle and two sides, or two different angles. And so we know for sure that if we're given three side lengths in a triangle, we're always going to get the same triangle. But in a quadrilateral, if we're given the side lengths, it's not always a guarantee we'll get the same quadrilateral. With the angles involved, sometimes we got triangles that would only work in one position, and other times we were able to create more than one. So we'll look at some of those criteria and get a little bit more in depth on when identical things can be created and when we can create more than one type of triangle. And we'll learn more about that in the upcoming lessons.